Einstein's general theory of relativity is famous for its prediction of wormholes, shortcuts that might allow time travel by connecting different areas of space and time. Nobody's ever seen one though, and debate rages over whether you could travel down one, even if they did exist. While we wait for a visitor from the future to let us know, here are some other physical impossibilities that might already have been proved possible. Welcome to another episode of Fast Facts. Subscribe to our channel to stay up to date with the latest uploads. Let's get into today's video. Perpetual motion machines. The idea of devices that can move and do other sorts of useful work with no external power has seduced some famous names over the centuries. Leonardo da Vinci worked on several designs involving spinning weights. Robert Boyle imagined a funnel that feeds itself. Blaise Pascal wisely abandoned the search and invented the roulette wheel instead. Large-scale perpetual motion machines offend against all sorts of physical laws, not least the cast-iron laws of thermodynamics. But Nobel Prize-winning theoretician Frank Wilczek's time crystals, materials that eternally repeat in time with no external power source, seem to come close. Examples recently made in the lab don't do any useful work, however, and so the quest continues. Teleporters. Ever wish the ground would swallow you up and spit you back out somewhere far away? Strangely enough, there is nothing in the laws of physics to stop that happening. In his 2008 book, Physics of the Impossible, physicist Michio Kaku calls teleportation a Class 1 impossibility, meaning that the technology is theoretically feasible and could even exist within our lifetimes. In fact, teleporters already exist, not for whole human beings, but for subatomic particles. Quantum entanglement, the phenomenon that Albert Einstein called spooky action at a distance, allows information in quantum states to be transmitted apparently instantaneously across space. The first quantum teleportation experiments, carried out in 1997, involved one photon's quantum state being reconstructed in another photon tens of centimeters away. Today, the world quantum teleportation record stands at over 100 kilometers. Invisibility cloaks. Harry Potter's invisibility cloak is just one fictional example of magical garb that makes you disappear. But so-called metamaterials suggest a similar possibility in real life too. The first metamaterials were made in the lab in 2000, and basic cloaking devices soon followed. Cloaking has recently been ruled impossible for human-sized objects, but that's no great loss. Even if it were possible, you would only be able to reroute specific wavelengths of light, making the cloaked object weirdly colored and more conspicuous. Instead, similar cloaking principles might be used to divert seismic waves and shield entire cities from earthquakes. Negative temperatures. If you want to live in this universe, you had better conform to its rules. No traveling faster than the speed of light, no dividing by zero, and no cooling anything below absolute zero. Absolute zero, about negative 273 degrees Celsius, represents the temperature at which atoms stop moving, so it seems logical you can't go below it. In fact, as physicists finally proved earlier this year, you can't even reach it at all. But you can jump beneath it. According to the strict thermodynamic definition, temperature is a measure of order. The quieter and more ordered something is, the lower its temperature. So, in 2013, physicists at the Ludwig Maximilian University of Munich in Germany took the logical leap. They tidied up a collection of atoms cooled to almost absolute zero just a bit more, creating a temperature technically well below absolute zero. Such states aren't practically very useful, but they might help us study dark energy, the mysterious stuff ripping the cosmos apart, as some have proposed it has negative temperature. Matter married with antimatter. Normally, when matter comes into contact with its opposite, antimatter, both annihilate in a sudden burst of energy. It's just lucky we live in a universe with a lot of matter and mysteriously little antimatter. But then again, bizarrely, some matter might also be antimatter. So-called Majorana fermions would be their own antiparticles capable of self-annihilating under the right conditions. Physicists have long suspected that neutrinos could fall into this category, although proving that means spotting some of the rarest process in the universe in action that happens perhaps once in 100 trillion years. Meanwhile, there are persistent reports we've made something similar in the lab. When an electron is torn out of a superconductor, a hole is left behind that acts like a positively charged particle with exactly the same mass. If the two are manipulated in just the right way, they can be made to act like Majorana particles. The principle behind metamaterial cloaks is simple. Waves of light bend around an object in your field of vision, much like water folds itself around a boulder in a stream. In practice, though, whole new nanostructured materials must be developed that can bend light in unfamiliar ways. And with that, we've reached the end of this video, all about the things that violate physics, but can potentially become true. If you enjoyed this video and found it helpful, don't forget to leave a like and subscribe for more content just like this. Thanks for watching, and we'll see you in the next one.